What's up, guys? It's Adam from ZFG Racing. Today we got the Explorer in the shop and we're going to be going over some of my data logging stuff, making some changes. We have our AEM 22 channel CANbus input module over here. And we're just going to be going over some general stuff and making some changes to our data logging setup. So as you can see, I have a back pressure monitoring sensor here for the exhaust manifold back pressure, or in this case it's just in the turbine housing. I haven't actually hooked that all the way up because I'm going to be changing it out. So originally we were going to go with an AEM setup, which has been fairly reliable for us, but for another part of a project I decided to order some RIFE sensors, and while I was doing that, I decided, hey, why don't I just get a 4-block for all the things that I needed in there? So went on to motionraceworks.com, ordered up a RIFE back pressure sensor snubber, essentially. So this is going to reduce the amount of pulsiness that the back pressure sensor sees. And then I ordered a RIFE Sensors 4-sensor block. And I got 2 5-bar map sensors in here, a 100 psi and a 150. So the 150 we're going to use for the back pressure. The 100 we're going to use for coolant pressure eventually. And then the 5 bars are going to be used for turbo inlet pressure and turbo discharge pressure. So yeah, so we're going to go ahead and get that wired up. I'm going to show you a couple things. This CAN module was already installed into the car. I'm basically running it off of the relay box that we had already installed for the Nostrum flex fuel sensor kit. So I already have the power and stuff wired in there, and then I did already have sensors in here. One of the reasons I'm going away from the AEM sensors is because I do not like their connector styles. In the process of me taking the intake off a couple times, somehow the wires got pulled out of the one sensor that I have in the intake right now, and it just, like, they don't lock in good. I don't like them, so we're just changing them out. The RIFE sensors use Deutsch connections, which I'm a big fan of. That's what I prefer to use on everything. So we're gonna go ahead and do that. So I'm gonna go ahead and walk you through this process. But for now, I gotta look some stuff up on the computer and pull up the wiring diagram for the AEM and the RIFE sensors, and we'll decide how we're going to integrate it all. All right, guys, I got both of these pulled up and I'm going to attempt to show them to you. So on the AEM, like I said, we already have the battery and stuff wired in. Where it says AEM CAN network, we're just on the HP tuners. In case it's an RTD, but RTD or MPVI, they both have that little pro module that you can run a CAN network to. That does not go through the car's CAN network. It is a separate CAN network, but it is able to be logged. We'll be using 7 as our dedicated sensor ground, 9 as our sensor power. Sensor wise, we're going to be using 23, 24, 25, and 26 as our 5-volt sensor inputs, essentially. And we will be using all of those. As you can see, you know, you guys can go pull this manual up outside of this video, but not everything can be used as an analog sensor. There's a couple digital ones for frequency, like duty cycle and stuff like that. There's different kinds of analog ones. You do actually get quite a bit of 0 to 5 volts, but some of them can also be used as like an RTD input or a thermistor type input, and then there's some ones that are dedicated to temperature via resistance. On the RIFE side, again, this is just from their website. No secret here. You can see we basically just need a 5-volt in, we need a sensor ground, and then we have 4 signals, and that's all on the Deutsch connector. Now, when I bought the RIFE sensor, I did just opt to get their pre-wired harness because convenience, I guess. But it is just, or it looks like it is just a standard Deutsch DT. I do think that mounting wise, I'm just going to 3D print something that goes from here to here. These holes aren't on the same plane, so hopefully I can just draw something up quick and 3D print something that'll put it on a nice flat plane, and then I'll have the sensor block sitting like this. But that's the goal. And then hopefully with this mounted here, then I'll have nice short runs to the back pressure sensor, and then, like I said, I already have a spot for turbo inlet pressure. And then these CV Fab charge pipes have spots for discharge pressure. And then coolant pressure, I don't know what I'm gonna do. I'll probably maybe drill a hole and tap there. I may just put it in the expansion bottle, to be honest with you. And that's what all of these sensor inputs are. They're all 1/8 inch NPT, except for this N1 is a 37-degree flare, just because the back pressure sensor comes with a braided line that'll plug right into that. And obviously on this side, on the RIFE sensor, or the snubber side, we'll be able to just go 1/8 inch NPT to the flare. I'll have to get another 1/8 inch NPT to 37-degree flare on that side. And I believe it's all -3, but don't quote me on that. So anyway, that's kind of the plan. I will walk you through some of the process. Like I said, I already got the connector split open here. What I'm probably going to do is use the pigtails from this, and then I'll just terminate that into a Deutsch connector that'll just live in the engine bay somewhere, just for simplicity's sake on my end. That also gives me the ability to change the harness at some point if I want to. Like I said, I'm not a big fan of AEM's connectors, but I have that logger already, so that's what I'm working with. So we're going to continue to try and use that. So I'm going to go ahead and get started on some of this wiring. All right, guys, as you can see, I got that knocked out. I'm just using a Deutsch kit. You can find them on Amazon. They're a little pricey for what they are, but you get a bunch of different connections that really comes in handy. And then I just have another Amazon Deutsch service kit, which has crimpers in it. You use that to crimp your main part of the pin. And then this is used to crimp like this little outer part of the pin on the back side here. So the main crimp is down here and the little outside part is there. Anyway, so we're going to switch over to the AEM side and get that wired up and cut those off and get them in the other side of the Deutsch connector. Basically, I forgot, this is actually a lot easier to depin than I thought. It's kind of a Deutsch style connector, that it's very similar, but this little plastic retainer piece pops off, and then you can just bump this little plastic latch out to depin it. I already put the extra two in. This is 23, 24, 25, 26. So that'll be all of our analog inputs. We're going to cut this down. This is sensor power, sensor ground. Like I said, I already had that there. We'll cut this down, get it in the Deutsch connector, and then we should be good to go. And we'll be done with the wiring on this part of it. And then we'll jump over to the computer and try to whip up some CAD files so that we can 3D print to mount that. So a quick little update up here. We're up in the office, and in order to mount this, I said I was going to design something and 3D print it. So I just wanted to quick show you that. We got this little guy drawn up using two of the existing holes on the shock tower on the driver's side, right where we wanted to put it. Kind of a simple looking bracket looking thing here. Not 100% happy with it, but it'll do the trick. So I went ahead and I 3D printed that. So again, nothing crazy looking, and all we're going to do here is put nutserts in. So the walls are extra thick here, so the nutsert has something to grab onto. But yeah, that's going to be the simple bracket. So let's head back out and go put it in the car. All right, guys, we were able to get our sensor block all mounted up on our 3D printed bracket. Again, this is just using 2 of the factory holes like I showed you in the 3D model. Looks pretty good, pretty solid, not going anywhere. And then bolted it down with the 1024 screws that Motion recommended for those. Those are like an 87-degree bevel on those. And then I just ran socket head cap screws up through the bottom, through the existing holes. No need to drill any new holes or anything like that for that. So that's where we're going to be with that. I'll probably bring you guys back as soon as it's ready to fire up. And as soon as we get, well, probably after, because I'm actually going to fire it up here pretty soon and go drive it around without the exhaust back pressure, because I don't necessarily need that. But I am going to put the hoses on for the turbo inlet pressure and hot side discharge pressure of the turbo. So I'm going to go ahead and put the DOT line on for that, and then I will check back in with you guys once I'm ready to finish the EMAP install. All right, guys, so we got this RIFE sensor package finally done. I ended up having to order some -3 stuff because originally I don't know why I thought this whole line set was -4 or -3, I mean. So I ordered everything in -3. Unfortunately, the line is actually -4, which is fine because the little RIFE sensor snuffer has MPT on each side, so you can put whatever fitting you want in there. So I got -4 on that side, -3 on this side. And then these other 2 sensor spots right now, they're set up for 5-bar sensors, because one of them is on the intake side of the turbo, right down here, which you guys can't really see. Let me see if I can turn some light on. So on the intake side of the turbo, there's one there, and then there's one on the discharge side of the turbo. So we'll have inlet and outlet pressure. That'll help us better calculate the pressure ratio of the turbo when we're doing our R&D work here, as well as EMAP. And then I have this last 100 psi sensor hole earmarked for engine coolant pressure for when we really start to lean on this thing, or if we compromise the head gasket, we'll see some pressure in the reservoir or in the cooling system under boost. So I don't anticipate having any issues like that. But it's always better to be safe than sorry. Had an extra sensor spot, so my intention is to just run right into the degas bottle. I'll just drill and tap. This is thick enough that I can get away with drilling and tapping for an 1/8 inch MPT, and then I'll just run the same DOT line over to the sensor block. But for now, we're just going to be running those couple of sensors and couple of channels, and of course this is wired into our AEM 22 channel, which is under here. That 22 channel box is CAN networked right into the RTD in this case, or RTD or MPVI, depending on which one you're using. But that'll give us all the data from all the analog channels on the AEM. So super excited about that. We'll have all that information inside of HP Tuners. Right inside of the data log. There is some issues with being able to translate the information, so we'll probably have to bring it out of Excel or bring it out into Excel to be able to translate the data. But that's fine, we can work with that. I don't need this data in real time. This is more like analyze it over time data anyway. So yeah, so I'm gonna get this set up on VCM scanner and then go take some data on these turbos. But that's going to do it for this video. Again, this video really just covered, you know, just a little R&D idea of how we took the 3D model, came up with a spot for our sensor block, modeled, you know, a little bracket in SolidWorks, 3D printed it, put some rib nuts in it, got it in the car. So anyway, I just wanted to cover some of that process of how we add sensors, or you know, if we need to add more sensors down the road, we'll use a similar process to that. But I just wanted to give you guys some insight on that. So that's going to do it for this video. Until I see you guys next time, stay tuned.